Hello, ladies and gentlemen. Welcome back. With the new school year, we now have a new course for us to take care of. Specifically, this year I am worthy of having students who are in honors geometry. Hooray! Hi! I hope I do well by you. So, what we're looking to be doing right now is these are going to be topic request videos. I only have the 2 students, so I don't have to worry about covering a giant broad section of material. So my first set of topic requests came from one of my students. He has basically 1 or 2 topics away from finishing goal 2, and the 2 topics he had wanted to cover were conditional statements and proofs involving congruence. So let's scroll down and start looking. When we're dealing with conditional statements and deductive reasoning first, this is not my favorite topic, not because the work is hard, it's actually very straightforward, but you're taking a lot of different things and then dumping them in one topic. So you're going to be looking at truth statements, specifically something called the contrapositive. You're also going to be looking at the law of detachment, and then the one that's the most fun to say, you're going to be looking at the law of syllogism. Not that I can spell, apparently. Good job, Ms. Dubois. Syllogism. Okay, so what do these things actually mean? First things first, I want to get something very, very broad. All of this deals with what's called if-then statements. You've had prior exposure to this in earlier topics. You had conditional statements up here, and then you also had a brief introduction to converse, inverse, and contrapositive when you were looking at earlier topics. So in theory, this should be nothing new, but just in case you need a recap, if you have an if-then statement, it's going to look like something as if something, then something. Let's make this as abstract as possible, because in the software it says, if the sky is blue, then it is geometry or something like that. So what's as generic? We'll say if P, then Q. When you start flipping things around, say for converse, inverse, and contrapositive, what you're going to be looking to do is specifically you're going to be flipping this. So how do I say this? You're doing a lot of things for a contrapositive. You are flipping your words, you're flipping your P and Q, and then the other thing you're doing is you're inserting the word not. In other words, you are inverting what you're saying. So a contrapositive means if not Q, then P. So when you're looking at these 2 topics, you see what statement must also be true. What statement must also be true? This then is what you're doing, not Q, not P. So in this particular case, you can see geometry is the favorite, therefore dress is on sale. If we're reversing that, then you're going to say the dress is not on sale, then geometry is not the favorite subject. That's the kind of work that you're doing for this. So what must also be true? We're going to take these 2 statements and flip them and then insert the word not. So the window is not above the door. Then Melissa's cousin is not a girl. So the cousin is not a girl. That's going to be the setup. The next thing you're going to see is the law of detachment right here. What's going to happen here is you're given an if P then Q statement. That part makes sense. Then you recognize detachment because you're going to be told P. And you can see that right here. Here's your if then statement, and then look here, tires are old. That's a copy and paste of the earlier thing. So this one is your hint that it's going to be detachment. And all you're looking to do, since you're detaching, what you're doing fundamentally is that you are breaking apart your P and your Q. So if you're told P like you are here, the expectation is that you're going to be writing your Q, which in this case is Dale knows how to dance. Over here, the instructor hates to fly, then the wall has been painted. Our instructor hates to fly. Our instructor hates to fly. There's our P, bold, underlined, and italics. So what's the expectation? We're going to write our Q. The wall has been painted, and that's going to be what you're doing from your selection box. Then syllogism. Syllogism is my favorite, like I said, just because I love the word syllogism and I never have the excuse to actually say it in the real world. What syllogism means is you're going to have not one if P then Q, you're going to have two of them, and that will get confusing. So let's break that up. We have if P then Q, that's our first sentence, and then we're going to say if Q then R. So you can kind of see we have a little bit of repetition. You can see Q here is repeated 2 times. What we want to do, if you know from your old-timey movies, there's a phrase, cut the middleman. What we're doing for the law of syllogism is we're actually cutting out all of your Q's. So you're left with P and R. So if we're looking down at this one, if that's Jessica's favorite joke, the river is overflowing, then the group has eaten lunch. There's your P, there's your Q. That's what you're expected to write for this answer. So you have your favorite joke, and then you're going to say you have eaten lunch. That's what you're looking for this. So fave subject, then the dress is on sale. If the dress is on sale, then the TV is broken. So you have your P and your Q that you're using. In other words, the first and last pieces of this sentence. So you have your fave subject, and then you cut out the middleman and get right to the brass tacks to say that the TV is broken. And for shame that the TV is broken, that means life is going to be boring for teenagers and me. So that's how conditional statements and deductive reasoning work. Once you have sort of a basic understanding of these 3 things, which in the pencil paper days are generally kept a little bit more separate than they are in this topic, but here they're throwing it to you all at once, and now you know what the expectation is. Basically, if you can understand what the setup is, what the contrapositive is, how to recognize law of detachment when you see it, how to recognize law of syllogism when you see it, this topic becomes easier. The really fun one is the next one, proofs involving segment congruence. Now, when I was digging through in order to screen grab this topic, it came in a couple of different flavors, so I've gotten as many of them as I could find up on the screen. And there's going to be a third one later, further down. But what this is this is a soft introduction to proofs. So before I talk about writing this, we have to talk about what proofs are. You are going to have 2 columns. You're going to have your statement, and then you're going to have your reason. Reason is all of the laws or definitions that you've been taking note of, especially in Chapter 1. So you might have something like the definition of congruent. If you remember, this symbol, an equal with a squiggle over it, is the congruent symbol. You might have something like the definition of equality. There's a difference between something being equal and something being congruent. Equal means the value is the same. Congruent means everything is the same. Shape, size, proportionality, the works. The works. Thank you, other Ms. Dubois.
You're welcome, Ms. Dubois.
You're also, later in the chapter, going to come with actual theorems. So you'll have something, this is later, but just so you know, you'll have something like side, 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 or maybe the theorem CPCTC. I don't want to overwhelm you because there's a lot that comes into proofs. And proofs, if there's one thing that makes this an honors class, is going to be the proofs. You're not going to shake this after Goal 2. This will follow you for all the other chapters in honors geometry. Statements are things that are... Usually you're going to have them listed as equal to each other, or maybe you're saying 2 things are congruent to each other, things of that nature. So for example, these 2 things right here, those are statements. And then what we're trying to do is, let's see here, we have that, and then, yeah, okay. Then your proof, this line here is going to be your last line of your proof. And what makes these hard is that kids now actually have to think kind of on their own. And it's not that teenagers aren't expected to think, but I don't want to sound condescending, but rather this is such a new way of thinking, the learning curve is very steep. What generally happens for students when they're learning, they'll get a couple of new things and then they're going to be fine about it. For learning proofs, you have to jump a lot of information and then you can actually start getting your information set up and taken care of. So it's going to be breaking your brain in the beginning. I cannot cut that out for you, but hopefully as you go through and watch me write these proofs from scratch, no less, you'll have a better understanding of how this is going to work. My general recommendation when you start these out is you want to do your givens first. So we know that CF equals EG because that was given to us. That's one of the things you can say for a statement because this is your statements and these are your reasons. So if C, and here's another little tip and trick for you. For the sake of everybody's sanity, especially when you get to the proofs later in the course, you want to start to label things. So if I know that CF and EG are equal, I'm going to look for CF and I'm going to label it, and I'm going to look at EG and I'm going to label it with those little tick marks. The tick marks you should be familiar with from earlier and in chapter 1. What else are we told? We are told that CD is equal to EF. Where's EF? There it is. There you go. And now we want to prove that DF is congruent. So what we're looking for, our goal is we want this to be congruent to this. That's our win state. So we're going to keep that in mind as we go through this. Since we have our two givens, we have one of our reasons that we're going to be using. There is a dusty old thing that you were told about back in chapter 1 that you're expected to remember and now use it up again, because now instead of using it for algebra, you're using it for a proof. We're going to use segment, addition, postulate. I don't know what it's called in the software. I think it's called just segment addition. I could be wrong. I'd have to actually look it up. Segment addition, and my screen grabs weren't showing me. So what does this mean? Segment addition. We know that segment addition means you're going to take one segment and break it into two smaller ones. So for example, we have CF equals CD plus DF. So there's our big statement, CF, and it's our two smaller statements, CD and DF. That's what we're doing to break it down. There's one of our segments, and now we're going to have to do it for the other segment as well. So now we know that EG is equal to EF plus FG, and it's the same reason. This is segment, addition, postulate. And now, very, very conveniently, since we know that CF and EG are the same, well, good gosh and golly gee, why don't we set them equal to each other? So we now can say that CD plus DF, so that's this piece, equals EF plus FG. That's this piece right here. So what we're doing is this is substitution. Substitution. And I think there was a patch last year, but you don't have to explain what lines you're using for the substitution. So y'all actually have it easy compared to prior honors kids. Yay! Next, that's one level of substitution. Since these two things are equal to each other, that means we can set these two pieces equal to each other. Happy days. Now, what else can we do? Because none of these letter combinations kind of match yet, and that's going to be a little bit annoying. We want to make that less annoying. So what we're going to do instead is, since we know that CD and EF are the same, why not write them as the same thing? So we're going to use substitution again, and we're going to say, let's see here, we'll say EF plus DF equals EF plus FG. So here's where I did the substitution. It changed from CD to EF. There's your substitution. And now we're basically done. We're ready to set up. Since I have the same thing here and I have the same thing here, why look, those are like terms. So what if I just subtract them? I'm left with DF equals FG. Now that looks familiar. Yes, that does look familiar. That's what we were expected to prove. So all we did is a little bit of subtraction property of equality, and boom, there is a completed proof. And again, because this is your first introduction to proofs, it's a little bit new, it's a little bit shaky, so we're going to go through a couple more examples. What are we told for this next one? We're told that DF equals GH. So DF equals GH. I'm going to do my labeling. Then we're told that DE equals EH. Oh, I see where this is going. And let me guess, we're going to prove that EG, EG is congruent to EF. All right, so let's set this up. This is actually going to be almost the same number of steps. Let's find out. So we have our statements, and we have our reasons. Okay, first things first, our givens. So we're told that DF equals GH, that's been given to us. Then we're told that DE equals EH. Again, that was given to us, and you always want to start with your givens to make life smoother for you. Next thing we want to do is we're going to do shock of all shocks, this segment, addition, postulate again, in order to say that DF, which is my big segment here, DF equals D, I didn't see what letter that was, DE plus EF. And now we're going to do segment addition again, only this time with the other line. So we're going to say that HG equals GE plus EH. Again, nothing is new here. So what that means now is we can use substitution, and I'm going to, like over here, set my two things equal to each other. So DE plus EF equals GE plus EH. This is a pain to write in the actual software. I actually find it easier to handwrite. Now we're going to do substitution again. Substitution. Because we want to replace one of our easy segments. What are the easy segments that they gave us? They gave us our short segments, our DE and our HE. So let's see here. So we'll say that DE plus EF equals GE plus DE. See, this is the thing that got replaced. Instead of EH, I'm now writing it as DE because this tells us that the two of them are interchangeable. And since they're interchangeable, we're going to interchange. Now that that's all set up, we have like terms. We have DE and DE. So we're just going to subtract them. Subtraction property of equality to say that EF equals GE. There it is. EF equals GE. And we're done with our proof. For an introduction to proof, the fact that it's 1, 2, 3, 4, 5, 6, 7 lines, that's a little long for a beginner, but that's the kind of thing that you're looking at. And actually, so far, yeah, both of these have the same exact setup in terms of their proof. Let's see if our last one is the same type. Let's see here. What are we told? We are told that EG is congruent to FH. Okay, this one will be a different setup. And then we're told that EF is congruent to GH. All right, let's set ourselves up. Oops. There. So we have our statements and we have our reasons. We, again, as always, start with our givens. So EG equals FH, that was given to us. Then we're told, that's it. Wait a second. Oh no, because that's the proof, Ms. Dubois. Silly Ms. Dubois. All right, this one is set up a little bit differently. We're going to use something that's, again, from way back earlier. I'm going to put a little X here. This is a trick that I learned when I was writing proofs in high school and in college. When you write an X for me, for Ms. Dubois, that's a little reminder to myself that I'm doing something called the reflexive property. What that means is that you have something equal to itself. So A equals A, 1 equals 1, FG equals FG. That's the kind of thing that you're going to be using in order to set this up. And so we can say that FG equals FG. That's because of reflexive property of, is this congruent? No, this is going to be equality. We're not using congruence yet. Hold that thought. What else? Now we're going to use segment, addition, postulate yet again because we're going to be breaking this up. Now up over here, you kind of gave you the segments because they were very obviously set up. So you had like, one very obvious segment and then another very obvious segment. Or over here you have the one vertical segment and then the one horizontal segment. Here, they're not as obvious, but you can kind of see that there is a segment. They do technically give you the segments, the EG and the FH. So what we're going to do is we're going to say that EG equals EF plus FG, which is the cinch for this. See what happens. Then we're going to use segment, addition, postulate again. And so we're going to have FH, oops, H, Ms. Dubois, I can type, equals FG G plus GH. And since we've been told that these two things are equal to each other, shock of all shocks, substitution yet again. Substitution, we're going to say that EF plus FG equals FG plus GH. So I took this piece and I took this piece and I set them equal to each other in an actual equation. And oh look, we have an FG and an FG. How convenient. I wrote it backwards some reason, but how convenient. So FG. The computer won't care if you write it backwards like I did. And then, almost exactly like we've been doing for all of the other proofs, we're going to use subtraction property of equality to get rid of those in order to say that EF equals GH. That's what I did wrong. Wow, Ms. Dubois. I was not reading my own handwriting. GH. This is what I'm looking at. GH. That's why I... GH. Looks like a 6 instead of a G. There, now it looks like a G. And there is our last line. EF equals GH, EF equals GH. Therefore, we are done. And then you'll have to, when you hit validate, it will say, huzzah, your proof is complete. And then you'll have the problem done. So, those were the two topics that were requested of honors geometry. If any other honors geometry students have topics that are particularly difficult, let me know, send me an email, and whatever Saturday that is, I will set myself up, write up a video tutorial like this, and then post it online. As always, stay happy, stay healthy, stay safe. See you next time.